And let's look at our trapezoid. Okay, so your trapezoid looks something like this. So what they tell you, again, with your trapezoid, is that you have exactly one pair of parallel sides. So that's going to be the top and the bottom. So that's going to be this. Now again, it depends on which way it's turned. If it's on its side, it's not going to be. So this side is going to be parallel to this side. Okay? So we've got these two parallel to each other. So that's exactly our one parallel. Now these two are the ones that are slanted. So those are not going to be parallel to each other. Because remember, they've got to be straight lines in order to be parallel here. So they're not going to be the parallel. So it says that we have exactly one pair of parallel sides, and the parallel sides are called the bases. So that means this one and this one. Those are our bases. Okay? So those two are our bases. Now it also says the non-parallel sides. So that's your two slanted sides. So that's these two, your two slanted ones, okay? That's going to be your legs. So the two slanted sides are going to be your legs. Okay? So I'm going to put that on the inside here. So those are your legs. Those are the ones that are not parallel. Okay? So we've got two parallel sides that are called bases. We got the two on the ends here that are not going to be parallel, that are going to be called your legs. Now, what this bottom piece says here is that if the legs are congruent, so if these two pieces are congruent, then it's going to be an isosceles. Now, these two do not have to be congruent. One of these can be longer than the other. But if they are congruent, then it will be an isosceles. So don't assume it's always going to be congruent. It will sometimes, sometimes it won't. But if it is, it's going to be an isosceles. So any questions at this point? Now, I've got a couple of things that I need to tell you about isosceles trapezoid. Because that's some of the ones that they're going to be working with. Why they only work with isosceles, I don't know. But that's the ones that they want to tell you about. So, I believe you've got 3. So I'm going to do it like I did before. I'm going to divide this up into 3 pieces. So I'm going to divide this bottom piece up here into 3. So I've got 2 here, and then I've got this bottom piece. So I'm going to fit 3 of them in here. So divide it up into 3. If you need to go to the back, that's fine. I don't know. I just like to keep them together so that way you can see all 3 of them. Now these 3, like I said, are talking about isosceles trapezoid. Okay? So, in here, all of them are isosceles. So I'm going to draw a picture real quick. Now remember, in here in the isosceles, your legs are congruent. So it needs to kind of look exactly the same. So here's my first picture. So here is my first one. And once again, we know that this one is parallel to this one. So I know those two are parallel. That's always a given here. Now, this one is labeled as 6.21. Remember, we keep getting these. Really doesn't mean anything. It's just the way it's labeled. It says if a trapezoid is isosceles, if it is isosceles, then each pair of both angles is congruent. So, okay, so I wrote, if it is isosceles, then each pair of base angles are congruent. And of course, we already know that if it's isosceles, what do we know about the legs? What did I tell you about the legs? In the isosceles, the legs are congruent. Okay? So, we already know in an isosceles, the legs are congruent. Now we found out if it's an isosceles, now each pair of base angles are also congruent. So what does that mean? Well, we already knew this because of what I told you right here. The legs of our trapezoid are congruent, then an isosceles trapezoid. So, we already know that part. Now it's telling us that each pair of base angles are congruent. So, where are the base angles? The base angles, that would be these two. Guys, remember your base are the two that are parallel. So the ones on this parallel line are congruent, and the ones on this parallel line are congruent. They're not congruent to each other. The top two are congruent, and the bottom two are congruent. So now these two are congruent. So the two on the top are congruent to each other, and the two on the bottom are congruent to each other. Now that's only if it's an isosceles. If it is an isosceles, then each pair of base angles are congruent. Okay? So you got the base angles, top and bottom, plus you got the sides in between. Any questions right now? Okay, then let's go look at the second one. The second one is 6.22. Okay, we're going to have another trapezoid. And this one says if a trapezoid has one pair of congruent base angles, then it's an isosceles. I don't know really why they need this one. We just covered it in 6.21. But we're going to have another one. So you can draw the same one, you can draw a different one. It really doesn't matter. So I've got my trapezoid. Again, I have my two parallel lines. And of course, since it's isosceles, I know my two sides are congruent. Now, in this one in 6.22, it says, if a trapezoid has one pair of congruent base angles, then it's an isosceles trapezoid. So I'm going to put that here. If a trapezoid has one pair, make sure I can get that in the screen. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So if a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So if we know that we have a trapezoid and it has, of course, our parallel lines, we know that we have the legs that are congruent, and all we know is that we have one pair. So if I say all I know is that I have these two that are congruent, what it's telling me is that if I know what you see right now, then I know it's an isosceles trapezoid. As long as it has one pair. It doesn't necessarily have to have two. But as long as it's got one, it is automatically an isosceles. Now, if it's got one, what do we know? It's automatically got two. That's what we know. So it's telling you that if you see this and they don't tell you that it's an isosceles, you should know this. That if you see your parallel lines, you see that the two sides are congruent, and you see that it's got one pair of base angles, you should automatically know that it's an isosceles trapezoid. Okay? Therefore, what do we know about isosceles trapezoid? We know that they've got two. So they may not always tell you that it's an isosceles, but you're going to have to know by looking at it. Okay? Does that make sense? This means yes, this means no, this means I don't have a clue what you just said, Miss Sullivan. So is everybody okay? Because if you get a picture that looks like this and they don't tell you it's an isosceles, you're going to have to know by looking at it. As long as it's got one pair, it's an automatic isosceles. Therefore, if it's automatically got one, it's automatically got two. Okay? And the last one, 6.23. 6.23 says that a trapezoid is isosceles if and only if its diagonals are congruent. So now we know once again that its diagonals are going to be congruent, just like the other ones that we've already had. So go ahead and draw your trapezoid, just like we've been drawing, and now you're going to put in your diagonals. So go ahead and draw your trapezoid.
Teachers, pardon the interruption. Students, at this time, we need the TAP classes of Hardrick and Funderburg to report to the library for pictures. TAP classes of Hardrick and Funderburg.
Okay, so we know we've got our parallel lines. We know that we've got our diagonals. We know that we've got our congruent sides. Now, what did it say? It said a trapezoid is isosceles if and only if its diagonals are congruent. But a trapezoid is isosceles if and only if its diagonals are congruent. So, what does that mean? So, we now know that for it to be an isosceles, these two now have to be congruent. So that means this one now has to be congruent to this one. So if one of them is 20, the other one has to be 20. That's only if it's going to be isosceles. Now, if they are not congruent, then it's just a regular trapezoid. So they have to be congruent. So, any questions? So we've got the base angles are congruent. We've got the diagonals are congruent. And we've got them telling us that if one pair is congruent, then it's automatically isosceles. So, any questions? Okay. Now, these questions are not that difficult. So, if I draw a trapezoid, and again, it doesn't matter how big, how small, doesn't matter anything. It's just a trapezoid. Now, again, I've got diagonals. Of course, it's kind of hard to draw a diagonal the way mine looks. Now, in here, I've got JK, LM. I've got N here in the middle. Now, what they're going to tell us in this picture is they're telling us that the measure of angle JML is 130. They're telling us that KN is 6.7. And they're telling us that MN is 3.6. They want us to find, the first thing they want us to find is the measure of angle MJK, and the second thing they want us to find is JL. Now, you're going to have to use some of that prior knowledge. Now, go back to some of the things we were doing on the worksheet on Friday. How many sides does this have? 4 sides. So, I've got to find the interior. How am I going to find the interior measure? You just did it on the worksheet. Okay. It's going to have to be that same thing. I don't know. I always know that a triangle is 180. But every other shape changes. So I need to do that same exact thing that we were doing the other day. I need to do that n minus 2 times 180. That's going to tell me how much all of these angles total are going to equal. So it still applies here. So I'm working on A. So I'm going to have to do the n minus 2 times 180 to find the total inside. So now, inside, I know there are 4. So 4 minus 2.
At this time, we need the top classes of Merriman and Coach Brooks, Jeremy Brooks, to report to the library for photos. That's Merriman and Coach Jeremy Brooks.
Okay, so 4 minus 2 is going to leave me with 2. So 2 times 180 is going to leave me with 360. So I know everything inside has to equal 360. Now, what do I already know? I know one of the angles is 130. Now, an important piece I did not tell you is that this is isosceles. So if this is isosceles, what do I know? Yeah, I know if JML, which is JML, that's this angle. So if this angle is 130, what else do I know? Which one's 130? That one. Because what did I tell you? The two base angles side by side here. These two would be the same, and these two would be the same. So if this is 130, that's also 130. Okay? So I already know 2 of them. I know this is 130, and I know this is 130. Simply because I know it's isosceles. Okay? Now, what am I going to do from here? I know these 2 plus I know the total is 360. What can I do? I can add these 2 and subtract it from the 360. So if I add my 130 plus 130, I'm going to get 260. So now if I subtract that from 360, I'm going to get what? 100.
No.
So now, how is that 100 gonna tell me what these two are?
Split it in half.
Split it. Why?
Because of the lines, you gotta,
Because what did I tell you about an isosceles? They have to be the same. So if these two were the same measurement, these two have to be the same measurement. So if these were both 130, then these two are both going to be what? 50. Because you had 50 left. So if you split it, or divide it by 2, what is each one of them going to be? 50. So all you had to do was 100 divided by 2, and it told you that each one of them would be 50. So I'm really not using a whole lot of information that I didn't already know, other than the fact that I know in isosceles, I knew that the angles had to be congruent. Okay? So I know that this one was 50 degrees. Simply because I had to use what I already knew, what we used on the worksheet, what we've already used before, and then I simply added the two because they were congruent, subtracted it from the total, and divided it by 2 because the 2 remaining pieces were congruent. Now, JL. What I do know now is that KN, that's this piece, is 6.7. So I know from here to here, this is 6.7. And I know from M to N, this is 3.6. Now, how is that going to help me find JL? Because JL is this line. There's not even any numbers on that line. How's he going to help me?
if you add 3.6 and 6.7, and if you get that, can't we use the same thing for JL?
Why?
Because
Because it's congruent. I just got through telling you that in an isosceles triangle, the diagonals are congruent. So if I know one of them, I automatically know the other. So if you add these two, that answer is going to be the same as this answer. They are exactly the same. So if you add your 6.7 and your 3.6, that's going to automatically tell you what JL is. It's not on JL, but those two lines are exactly equal. Because JL is congruent to KM. So if I know one of them, I automatically know the other. So what is 6.7 plus 3.6? It's 10.3. So my answer is 10.3. Question. So you have to think about this. It's not really any different than some of the other things that we've talked about. We know that in some of the other ones, the diagonals are congruent. In some of the other ones, we know that the angles are congruent. But you got to stop and think about it. It's not going to immediately jump up. And this one was actually easier to solve than some of the other ones that you had to do in your homework. I didn't have to solve an equation. I didn't have to do anything else. This one was really quite easy. I just had to stop and think about what I was doing. Question. Okay, I need to show you, I'm not gonna finish this, so we'll end up having to finish it tomorrow. But I do need to show you the mid-segment. So draw another trapezoid real quick. Okay, we're going to do real quick the trapezoid mid-segment theorem. So I'm going to draw another trapezoid. So once again, I know that the top one is parallel to the bottom one. Now, what this says is that you have the mid-segment. The mid-segment is going to be parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. So your mid-segment is going to be here in the middle. Your mid-segment is here in the middle between the two bases. Okay? It is still parallel. Okay? So it is still parallel. So this is your mid-segment. So it is, the mid-segment is in the middle, it is still parallel. And real quick, I'm going to add some letters. So we're going to have A, B, C, D, E, and
At
F.
this time, we need the top classes of Coach Bone and Coach Stewart to report to the library for pictures. Coach Bone and Coach Stewart.
Now, what this says is that the mid-segment is this line here. So it's going to be this line BE. So BE, which is your mid-segment, that line right here, it's going to be equal to 1/2 of what you get when you add the top line plus the bottom line. So it would be your two bases. So I'm going to put top and bottom. So what you would have to do is add the two, add your top, add the bottom, and divide it by 2. And that's going to tell you what your mid-segment is. Okay? Now, at the same time, that mid-segment, this mid-segment in your picture, it's going to cut these sides in pieces. So what I now have is this piece is now congruent over here. Because it is the midpoint now. So it is now cut these pieces in half. So it's now cut this piece in half, and it's now cut this piece in half. So basically what you have, when you have your mid-segment, is it forms your midpoint here on the side. Okay? And we know the midpoint does what? It cuts that line in half. So when you draw this mid-segment, it's gonna divide your side in half over here. That may come in handy somewhere down the line.
Okay, you just lost me.
Okay? What? Your mid-segment,
I get the,
you got this part in here.
yes.
Now, that mid-segment, when it touches this leg over here, it's gonna divide that in half.
Is that for both sides?
Yes. Now, I'm not necessarily saying that this side is gonna be equal to this side. All I'm saying is that when it touches this side, it's now cut these two in half.
So, are
This top part is now gonna be equal to this part.
Okay,
And this part is now gonna be equal to this part.
okay.
I'm not saying this is equal to this. I'm saying that this is equal to this, and this is equal to this.
Okay.
Okay, that's all it's doing, because when you have a midpoint cuts that line in half,
Okay.
right? So you have to add these two and divide it in two to get this. And when it touches the side, it's now automatically cut these two in half.
Okay.
Okay, now what I will do is I will give you some practice on as far as we got. Okay? So, you will have some practice on working with some isosceles trapezoids and stuff. And I may give you a couple of these to see what you can do with them. Now, we have not even begun to look at the kite. So we've got a couple of things we got to look at in the morning. So try it. Chances are, I don't know if you will get anything on the iExcel. You may get a worksheet, and it may not be very many, because we didn't get a whole lot of stuff done.